Okay, let's take a look at relative density. Relative density. So, you getting the relative density of a material means you are comparing the density of that material with the density of water. How does that density of the material relate to the density of water? Water here is used as the yardstick, as the measuring stick. So from the definition here, we have relative density equals to the density of substance or material divided by the density of water. And why did they use water? Water is the most common liquid. So getting the relative density of a material means you're comparing the density of the material with the density of water. So let's take a look at some materials and their densities and see how we can get the relative density of one of the materials. So here we have some densities, some materials and their densities. So we have the first one here is aluminium, we have copper, and we have their respective densities written here. So, but let's focus our attention on aluminium and let's see on aluminium and let's see how we can get the relative density of aluminium. And don't forget that we know that relative density equals to density of substance, density of substance divided by density of water. You must divide it by the density of water. Density of water. Okay, now from this table we have here, we know that the density of aluminium here is this, and it's 2.7 times 10 raised per 3. If you convert to ordinary form, it gives you 2,700 kilograms per meter cube. That's the unit. So going back to our formula and the calculation, we can now say relative density equals to the density of the substance. First of all, I'll start with the numerator and then I'll go to the denominator. Density of substance, according to that table, is 2,700 kilograms per meter cube. Then divided by that of water. Let's check the table again for water. Density of water is actually here. Okay, this is it here, and it's 1,000 meters. 1,000 kilogram per meter cube is the density of water. So I'll fix it there. So fixing it there, divided by 1,000. So divided by 1,000 kilograms per meter cube. So the units cancel out. That's why relative density has no unit, because the units will cancel out. And then if you now divide 2,700 by 1,000, you will get 2.7. So getting 2.7, there is no unit because the units have been cancelled out. So our relative density now is equal to 2.7. No unit. And one thing you should take note of is if the relative density of a material is greater than 1, it means that material will sink in water. But if the relative density is less than 1, it means the material will float in water. And we are using 1 because the relative density of water is 1. If you relate the density of water with itself, that's if you divide 1,000 by 1,000, you get 1. So relative density of water is 1. That is why we are saying that if you get a relative density of a material greater than 1, if it's greater than 1, it will sink in water. But if it's less than 1, it's going to float in water. So that's just it. So let's see another definition for relative density. It doesn't end here. So we have a definition again, and this time around the definition here is the mass or the weight of a substance divided by the mass or weight of volume of equal volume of water. And this particular denominator here is actually talking about the upthrust that the water is going to give to that particular substance. So if the mass or weight of the object is, let's say, 10 Newton, and you now immersed the substance in a liquid or in water, let's say in water. So let's say it's 10 Newton is the weight of the object in air. Then when you immersed it in water, it now weighed 8 Newton. The upthrust will now be equal to the weight in air minus the weight in water. So this was 10, it was 10 Newton in air and 8 Newton in water. The upthrust will now be 2 Newton. So this 2 Newton is the equal volume, is the weight of equal volume of water. So very easy. So we have a question that we could use this formula to solve. Let's go to the question immediately. So this is a question here. So it says an object weighs 2.7 Newton in air and 1.2 Newton when completely immersed in water. Calculate its relative density. Take note, this was the weight while in air. And the weight now reduced when you now immersed it completely in water. So we could use this formula to calculate this formula here to calculate the relative density of that particular question. So going back to the question, we'll just write out our formula. We'll say relative density equals to weight in air, or weight of the substance, over weight of equal volume of water. Weight of equal volume of water, equal volume of water. Remember, this weight of equal volume of water is the upthrust, and we know how we got the upthrust. So the weight of substance will now be, the weight of substance, of course, is in the question. This is the weight of substance, 2.7, so I'm writing that one out. So 2.7 divided by weight of equal volume of water. So going back to the question, it now weighed 1.2 Newton. So I will do the weight in air minus the weight in the liquid to get the weight of equal volume of water, or to get the upthrust, like I said before. So weight of equal volume of water will now be gotten by subtracting. We'll say 2.7 minus the 1.2 gives me 2.7 over 2.7 minus 1.2 gives me 1.5. And if you divide 2.7 by 1.5, you get 1.8. So 1.8 is the relative density of that particular substance, or that particular object. So there's another formula again we could also use to define relative density. And let's go to the next slide. We could also say that relative density could be the upthrust in liquid divided by upthrust in water. What's upthrust in liquid actually? Looking at this, upthrust in liquid is actually the weight in air of that object minus the weight of that object in that liquid. Very simple. While the upthrust in water is also equal to the weight of the object in air minus the weight of the object in water. That's it. So just slot this into your calculation and substitute, and you get your answer. So let's see a question that utilizes this particular definition of relative density. So let's go to the next slide. So we have the question here. So a solid weighs 5 Newton in air and 4.2 Newton in water and 4.4 Newton in the liquid Y. Calculate the relative density of the liquid Y. So this is very easy. Relative density, since they're asking you to calculate the relative density of the liquid Y, and they said it weighs 5 Newton in air and 4.2 in water, that means we can get the upthrust in water, and it now weighed 4.4 Newton in that liquid, then this work is very easy. So going by what we have from this question, this particular formula will help us out well. We'll just get the upthrust in the liquid and divide it by the upthrust in water. Still, we are still comparing it with that of water. So let's do that immediately. So we just say relative density equals upthrust in liquid divided by upthrust in water. Upthrust in water. Okay, so we know that upthrust in liquid is actually weight in air minus the weight in that liquid, then divided by upthrust in water is actually also weight in air minus the weight in water. And of course, from the question, we know that the weight in air is 5 Newton, weight in water is 4.2, and weight in, okay, let's write those parameters out. It will help us. So we know that weight in air is 5 Newton. Weight in liquid is what? Let's go back. Okay, is 4.4 Newton. So 4.4 Newton, 4.4. Then weight in water is 4.2. Weight in water is 4.2 Newton. So we'll just fix them there. So replacing everything in this formula, we'll have weight in air is 5 minus weight in liquid is 4.4 divided by weight in air again is still 5 minus weight in water is 4.2. So we end up having 0.6 divided by 0.8, and definitely when you divide you get 0.75. So that this will be the final answer, the relative density of that liquid Y. So this is the final answer here. So it's very easy, very simple. So in the next video, we're going to solve more examples using these same formulas.